In this video, we want to look at solving equations that contain trigonometric functions. Now, some of them are going to be start off very simple, like this one, 2 cosine of theta minus 1 equals 0, which you only have one trigonometric function. Isolate that, and then we can figure out what the values are. So, first, just add 1 to the other side, and then divide both sides by 2. So you get cosine is equal to 1/2. Now, just to remind everyone here about all students take calculus. Where is cosine positive? Cosine is going to be positive over in these two quadrants. So that's where our answers are going to be. And cosine is going to be 1/2. So think back to the unit circle that we did, those key values. And cosine is going to be 1/2 when you have a reference angle of 60 degrees. Now, what we want to do is we want to solve these over from 0 to 2 pi. So our answers are going to be, so the thought is our reference angles are going to be 60 degrees. But in terms of radians, because that's what we need, that's going to be pi over 3. So it's going to be this guy that's over here. So this would be pi over 3. But then you have one that kind of mirrors it across the x-axis, where it'd be pi over 3 going backwards. We don't want to say negative pi over 3 because we're restricting ourselves between 0 and 2 pi. The other value is going to be 5 pi over 3. So when we're solving this over 0 to 2 pi, these are the two solutions, the only two solutions that we have. However, cosine itself has a domain of all real numbers. So you can go all the way from negative infinity to positive infinity. And you're going to have an infinite number of solutions. It's not just these two guys, but as you keep going around and around and around on the unit circle, you're going to keep hitting this guy an infinite number of times. So we want to find a way of expressing all solutions. So for all solutions, we would say this, that we can just kind of cheat a little bit or be a little bit lazy and say this is going to be pi over 3. Because the period for cosine is 2 pi, we can say plus 2 pi, we can say 2 pi k, and then we have 5 pi over 3 plus 2 pi k, where k is an element of the set of integers. So as long as you're doing integer multiples of 2 pi, that means you would hit this, go around 2 pi, go around another 2 pi, you're still going to be hitting and having coterminal angles. So that means their cosine values are going to be the same. So setting it up like we have right here, this would be the format for coming up with every single solution that would ever be for this equation. All right, so let's look at this next one. We have the square root of 2 times the sine of theta plus 1. And we want to solve this for where our theta is between 0 and 2 pi. Oh, sorry, equals 0. Very important part there, because if I don't have that, I don't have an equation and I couldn't solve anything. So let's get this trigonometric function by itself first. So step by step, we move the 1 to the other side, and then we divide both sides by the square root of 2. Now, this is kind of gross. So we want to make sure that we rationalize the denominator, and we have negative square root of 2 over 2. Again, let's think about where our answer should be. Sine is going to be negative where? Remember, sine connects to the y values, and sine is negative down in quadrants 3 and 4, right? Because all students take calculus. So only in quadrants 1 and 2 is it positive, so it means sine is negative in quadrants 3 and 4. All right, so hopefully you have memorized those key values from the unit circle, and you know that when sine is equal to negative square root of 2 over 2, that means you have a reference angle of 45 degrees, or pi over 4. So that's going to be down here and down there. So our theta is going to be where you have this pi over 4 reference angle right there. So again, think about it. Every 180 is going to be a full pi, right? So it's pi plus a quarter. So 1 1/4 is 5 pi over 4. So it's 5, 6, that's going to be 7. So 7 pi over 4. At least that's how I think about it. I have no problems working with fractions or dividing up this xy plane or the unit circle into those nice fractional pieces. So there you go. Those are the only two solutions from 0 to 2 pi. Now, if it had said find all solutions, then you would have done something very similar to what we did up here, where you would say 5 pi over 4 plus 2 pi k, and 7 pi over 4 plus 2 pi k. But for this problem, it was just finding all solutions from 0 to